Good morning, everybody. Welcome to our nonlinear motion detector lab. In this activity, what you guys will be doing is similar to the constant motion detector lab, when you all were predicting the shape that graphs would take as a volunteer moved back and forth in front of a motion detector at a constant speed. We're going to be doing something very similar, except instead in this lab, we're going to be looking at what happens when a volunteer, which is going to be me, is moving back and forth at changing speeds. So our setup here, we've got our motion detector. This will be recording my position over time. So it's going to be measuring my position in meters as time progresses. We've got me, which is going to be the volunteer that's going to be moving back and forth. I have my whiteboard here, which is kind of a messy whiteboard that allows the motion detector to see me a little bit better. So here's what you all are going to do. I'm going to be describing a type of movement, and you are going to be predicting on, probably your notebook is the best bet, you're going to be predicting the shape a graph is going to make based on that movement. And then what I'm going to do is I'm going to start collecting the data. I'm going to have that graph visible so you guys at home can see it. And then you're going to draw the correct graph based on what actually happens. So a little bit of prediction, and then you're going to confirm whether or not that prediction was correct or not as I actually collect the data. So for example, in this first setup here, what I'm going to do is I'm going to be starting close to the motion detector, and I'm going to start backing away slowly and then speed up over time. So I'm going to start slow, so I'm going to be here. I'm going to start slow and then speed up as I move away. What you need to do is predict what shape that graph will look like. So take a minute, put in your notebook what you think that graph will look like, and then we will see. All right, so I have my setup here, all set to go. I'm going to be pushing the collect button, pushing the record button, collecting that data, and then you guys can see whether or not your predictions were correct. So to do a little bit of a stretch here, I'm going to be starting slow and then moving away and speeding up. All right, so looking at this is a little weird because I kind of had to reach a little bit, but you can kind of see when I started slow, I have kind of a nice flat gradual line, and then I speed up and the line gets steeper and steeper. So once again, this is a non-linear graph because my speed is changing. So if you think about it, if I'm going from slow to fast, I'm going to be going from a shallow slope, so a slope that's relatively flat, especially in this area here. But then over time, that slope is going to get steeper and steeper as my speed increases. Remember, the slope of a position versus time graph represents the speed of the object. So if I'm starting slow, it's going to be a flattish line that slowly becomes steeper as we go. The other part of this is I was moving away from the motion detector. Because I was moving away from the motion detector, the line is going up. It's a positive line. So in the next one, what you all are going to do, well, what I'm going to be doing is I will be once again moving away from the motion detector, but I will be moving fast to start off, and I'm going to slow down. So again, in this one, I'm going to be moving fast to begin with, and then I'm going to be slowing down as I get further away. I'm still going to be moving away, but now my speed is going to be changing, and you have to think about what that might mean. So I want you guys to go ahead and make your predictions for what you think it will look like when I start close to the motion detector. I start moving quickly as soon as we start, and then I slow down as we get further away. So go ahead and make your predictions, and we'll see what happens. All right, so we are ready to get started. So once again, I'm going to try and do my little my stretch here and see if we can find out what happens when I move away quickly and then slow down as time goes on. So we'll do a little bit of a stretch. right, so ignore this first part here. That was just me reaching for the computer again. But if you see, I start off moving relatively quick right here. So I have a steep slope, and then over time it starts to flatten out a bit because I start to slow down. So that's what you expect when an object is slowing down. It's going to have a steep slope to start with, and then as time goes on, that slope is going to get more and more gradual, just like it did here. Because once again, the slope of the line represents the speed of the object. So as I am moving away, I'm slowing down, so my slope is getting less and less steep. Now, in this next one, I'm going to be starting further away. I'm going to be starting more like here, and I'm going to be moving towards the motion detector in this one. So I'm going to be moving towards the motion detector, and in this case, I'm going to be starting slow and then speeding up, moving towards the motion detector. All right, so I'm going to be starting slow, then speeding up as I move closer to the motion detector. So go ahead and make your predictions, and we will see what happens. All right, so here I am. I've got my handy dandy board. I'm going to be starting a little bit further away, so I have some room to work here. I'm going to start the motion detector. I'm going to start walking slowly towards it and then speed up, and hope I don't run into it. So here we go. There we go. So 3, 2, 1. All right, so ignore this flat part of the line where I ran out of space to move. Just look at this part right here. So I started slow, so my slope is pretty gradual. But then as time went on, I moved faster and faster, and my slope got steeper and steeper. So that's the first part, is the slope was getting steeper. The second thing that you might notice is the shape of the graph is different because I am now moving towards the motion detector. Remember, if you're moving towards the origin, you have a negative line. So I now have a negative line that's getting steeper over time. So I have a negative line because I'm moving closer to the motion detector, and it's getting steeper because my speed is increasing. So for the last one, you can probably guess what we're going to do. I'll be moving towards the motion detector again, but this time I'll be starting fast and then slowing down as I get closer to it. So I'm going to be starting fast and then slowing down as I move towards the motion detector. Go ahead and make your predictions as for what you think that's going to look like. I'm ready to collect my data. When I start, I'm going to move fast to start off with and then slow down as I get closer. So I'm going to move fast to start with, slow down as I get closer. 3, 2, 1, go. All right, so in this one, I started fast, so I have a steep slope to start off with. But then as time went on, as I moved closer, I started to slow down, so that slope started to level off until it got to the very bottom, where I really wasn't moving all that much at all. Ignore this part of the graph because that's just kind of a jumble as I got a little too close to the motion detector. But once again, you can see I start fast, I have a steep slope, but then as time goes on, I get slower and the slope starts to level out as I get closer and closer and I go slower and slower. And once again, it's a negative graph because I am moving closer to the origin. So what's coming up next is you are all going to be doing a little bit of data analysis on this, a little bit of a lab, and seeing if you can pull out some general trends.